All right, here's the key to your final exam review. The segment PM has a midpoint N, and the coordinates are given to us. Basically, what I did is I constructed a line segment, PM, and placed the midpoint N in the middle. I listed the points that were given to me, and then I noticed the pattern in the x values from -3 to +4, that is adding 7. In order to find the missing endpoint, I'm going to add 7 more, which is 11. From here, I noticed the pattern in the y values, 16 to 10 is a -6 pattern, so I have to -6 again, and that gives me 4. So if I'm finding that missing endpoint m, it's going to be at 11, 4. Now, number 2, there are quite a few ways that you could do this, but I'm just going to list one of them. Find the coordinates of b, that is 3/4 of the distance from A to C. So I basically have a line segment A to C, and it gives us the points. It wants us to figure out where B is going to be located if it's 3/4 of the distance between that line. So the way we find that is we figure out what the distance is between the x values. Now, I'm getting my x values from the points given to me. 6 minus -4 is a distance of 10 for my x's. What I'm going to do with that 10 is take 3/4 of that distance, and I got 7.5. Now, what that means is from point A, I'm going to go to the right 7.5. So if I'm at point A, I'm going to go to the right 7.5. Now, I'll have to do the same thing for the y values. I'm going to figure out the distance between the y's. 11 minus -5 is 16. I take 3/4 of 16. That gives me 12. So what that means is I'm going to go up 12. So from my point A, I'm going to go up 12, right 7.5. If I do that on graph paper or on Desmos, I can see that that point is 3.5, 7. You can also do that by taking point A and adding 7.5 to the x value and adding 12 to the y value. Now, when I get that point, 3.5, 7, it is located in the first quadrant. And if you don't remember quadrants, I've got it listed right here. This is quadrant 1, 2, 3, and 4. So another way that we can figure this out is if we find the midpoint between A and C, it would be right here, directly in the middle. If I find the midpoint yet again, that will leave me 3/4 distance from point A. So 2 ways you can do that. I just showed one. Number 3, if I have a parallelogram PQRS, it gives me the equation of the line PQ. 2x plus 3y equals 7. It wants to know what the slope of RS is going to be. Now, since this is a parallelogram, that means PQ and RS are parallel. Parallel means they have the same slope. So what I'm going to do is just take this equation and put it in slope-intercept form. I minus the 2x, divide by 3, and my equation is y equals -2/3 x plus 7/3. If I want a parallel slope, that means my slope of RS is going to be -2/3. For number 4, given PQ is a line segment with coordinates P at 310 and Q at -4, -5, write an equation of the line perpendicular to PQ. So perpendicular means that we have opposite reciprocals for slopes. So what we're going to have to do is find the slope first of those 2 points. And then what we're going to do is we're going to pick a point. Then we're going to plug that into a point-slope formula, which you will be given these formulas on the test. And once you have that, we will get it into slope-intercept form. So we'll find slope, and then we're going to find that opposite reciprocal since it wants perpendicular. So I'm going to find my slope first. I'm going to use my formula y2 minus y1 over x2 minus x1. So that is -5 minus 10 in the numerator, -4 minus 3 in the denominator. Simplify, and I get positive 15 over 7. So since my slope for the 2 points given to me is positive 15 over 7, I want to flip that fraction and change the sign in order to get the perpendicular slope. So I flip the fraction, change the sign. My perpendicular slope is -7 over 15. So once I have that, I can take that slope and plug it into my point slope formula. I picked point P, 3, 10, just because it has no negative, it's less subtraction signs to deal with. So I picked 3, 10 for my point. My point slope formula is y minus y1 equals m x minus x1. That m is the perpendicular slope. Maybe I should write that on here because I don't want the original slope. I'm trying to find the line that is perpendicular. Right, so I'm going to plug in y minus 10 because that's my y1 equals negative 7/15, that's my perpendicular slope, parentheses x minus 3. What I'm going to do from here is just get y by itself. So I do have to distribute and then add the 10 to both sides, and I end up with y equals negative 7/15 x plus 34 over 3. Number 5, it says what's the postulate that proves that 8 and 4 are congruent to each other? Those are corresponding angles. Number 6, I'm going to leave this here, 6 and 7, so you can pause the video and remember what the converse, the inverse, and the contrapositive look like. So go ahead and pause the video if you need to. Number 7, it just says where are there points of concurrency. We spent a lot of time talking about this. Altitudes meet at the orthocenter, perpendicular bisectors meet at the circumcenter, angle bisectors meet at the incenter, and the medians meet at the centroid. Number 8 is a little bit tricky. I want to try to illustrate this as best as I can with 2 pens. Imagine these 2 pens are lines. So if I have 2 parallel lines, they are sitting on my piece of paper. They are on the same plane as each other. The question is asking which ones are not coplanar. Not coplanar means they are not on the same plane. All right, so parallel lines, they are. If I have perpendicular lines, pretend there's a 90-degree angle between my 2 pens. They are still sitting on that sheet of paper, so they are planar. They are coplanar. They're sitting on the same piece of paper, so that's not the right answer. If I have 2 intersecting lines, now imagine that these 2 are running through each other and not stacked on each other. Intersecting, they would still be on the same plane. Skew lines, however, would look something like this. One is facing one direction, and one is facing a totally different direction. Now, imagine these 2 lines are going forever in space. These are not on the same plane. They're not lying on the same piece of paper, so they are not coplanar. Number 9, you just kind of have to work around and find a place to start. I started at 154 degrees, and I noticed that these 2 are linear pairs. So if I do 180 minus 154, I get 26 degrees. From here, I notice 26 and this angle are alternate interior angles, which means they are congruent. That is also 26. Because this is a right angle in this bottom right corner, I know that up here is an alternate interior angle. So it is also 90 degrees. So I did 90 minus 26 to find 64. 64 and angle 2 are vertical angles, so they are congruent. And then again, this is a 90-degree angle here, so that leaves this with 26. Angle 1 is obviously 90 degrees because I've got 90 and then another 90. Those 2 are linear pairs. All right, number 10, it wants to know what relationship these angle pairs have. Now, we did a city planner project on this, and we basically had 2 streets running across a town and a transversal going across it, which gives us 8 angles, 1, 2, 3, 4, 5, 6, 7, 8. Now, it creates these special relationships, like 1 and 3 are vertical angles, 2 and 4 are vertical angles, 1 and 2 are linear pairs, 5 and 6 are linear pairs, and so on. We also learned about alternate exterior, so like 1 and 7. 2 and 8. Alternate interior would be 4 and 6, and 3 and 5. Corresponding means they're in the same position, so angle 2 and angle 6 are corresponding. Angle 1 and angle 8 are corresponding, and so on. And so you can take a look at their relationships here. Now, this only works if you have 2 parallel lines and a transversal cutting through it. So A has to be parallel to B in order for those relationships to happen. Number 11, it says identify the triangle that does not have all obtuse exterior angles. What you have to do is create exterior angles. Just take a ruler and create your exterior angles. Obtuse, obtuse, obtuse. This is equilateral. Remember, that means on the inside it is 60, 60, 60. So on the exterior, that's a linear pair. So 120, 120, 120. That means these are all obtuse, so obviously this one's the answer choice, and this is why. If I extend an exterior angle, that would be 90 degrees. Number 12, it wants to know which of these lines are parallel and perpendicular. What you need to do is go through and find the slopes of each of these. Now, I found the slope of M was up 6, right 5. The slope of T is up 1 over 1, up 1 over 1, up 1 over 1, so it's just positive 1. Line P, again, is up 6 over 5, and so gives us 6/5 as the slope. Q, I go down 1, right 1, down 1, right 1, down 1, right 1. And so remember, parallel means same slope, so that means M and P are parallel. Now, T and Q, they are opposite reciprocals of each other because remember, positive 1 is 1 over 1, and negative 1 is negative 1 over 1. Flip the fraction and change the sign. These two are perpendicular to each other. Number 13, it tells us, it doesn't give us the tick marks on the picture, but it tells us EF is congruent to FG. So I know a lot of you are tempted to be like, do I add them and set them to 180? No, these are side lengths. These are not angles. Angles on the inside add up to 180. So these are not 180. Just remember that if they're on the outside here, that means they are side lengths. Okay, it tells us these two are equal to each other. Set them equal to each other. Solve for x, you get x is equal to 4. But read your problem carefully because there will probably be an answer choice. X is 4 or something. You're not done. It says find FG. So I take FG and I plug that 4 in. 7 times 4 is 28, minus 21 is 7. FG is 7. Number 14, you will be given the distance formula on your test. Just remember, you label your first point x1, y1, your second point x2, y2, and you just plug it in to the formula. And if you have a minus negative, it becomes a positive. D is the one that correctly matches. Number 15, it says, which of the following equations would be parallel to the given equation? That one's pretty easy. M is 2 there. Parallel means the same slope. The only option that has the same slope is C. It's got a 2 as a slope. Number 16, it says, name 3 non-collinear points. Non-collinear means they are not on the same line. So we're just going to check our options. C, B, and D. C, B, D, they're on the same line. So that's not correct. We want them to not be on the same line. F, C, B. Notice F and C are collinear, but B is not on the same line as those two. C and B are collinear, but all 3 of these together are non-collinear. Number 17, it says, which triangle congruence postulate best describes the relationship between the 2 triangles? I've got a tick mark here and here, so these sides are congruent. I've got 2 tick marks here and here. Those sides are congruent. And remember, bow tie shape means vertical angles are present. So I've got a side, an angle, a side. Side, angle, side. It's SAS. Number 18, it wants us to figure out what range of values this could possibly be and what a side length could be for side CB. So I don't know how big it is. I'll just call it X. Now, remember, we have to figure out the range of values that X is between. We did that by minusing 12 minus 7. That's the lower bound. 12 minus 7 is 5, and then 12 plus 7 is 19. So I subtract them to find the lower bound. I add them to find the upper bound. X is somewhere between 5 and 19. 4 is too small. 23 is too big. 19, it cannot be 19. It doesn't say or equal to, so it's got to be 17. Number 19, I've got an angle. It gave me tick marks for a side. Vertical angles are congruent, so angle, side, angle. Angle, side, angle. All right, I'm going to leave this here so you can pause the video. Now feel free to ask me or your teacher questions. Some of these could be one or the other. Like if you look at E and G, technically those are both perpendicular lines, but one of them is segment bisector because this line segment is being bisected. It's giving me 2 tick marks there. So some of these, could be one or the other. Like linear pairs, you could have put supplementary, but it's trying to tell you that this is a pair of supplementary angles. You could also say they are adjacent. So some of these are iffy. So pause the video and make sure you have the correct solutions.